space solar power. Yes, that's energy from the sun beamed directly to us from space. Is that possible? We think it is. A recent 10-nation study of space solar power by the International Academy of Astronautics concluded that space solar power is now technically feasible and within reach as an economic enterprise. That study and other studies conclude that this energy can be generated in space and made environmentally safe on Earth. From a future perspective, we think space solar power is now an international necessity.
Every bold initiative starts with one small step. For decades, space-based solar power has been a discussion topic, mere speculation. Numerous plans have been proposed, but now is the time to do the science and engineering. What is proposed is a new type of experiment aboard the International Space Station, in which energy will be gathered in space and transferred to the ground. The space station is a working laboratory orbiting some 250 miles above the Earth. It is already equipped with solar panels to generate the electricity needed for life support and scientific experiments. We believe this station will serve as a convenient platform from which to test the relay of sun's energy to receiving stations on Earth. To make this test of wireless transfer of power an international effort, we are requesting the cooperation and assistance of at least 5 nations. While the energy generated may be only enough to power a light bulb about 4 minutes over a single Earth receiver, the space station passes overhead multiple times over multiple nations in a given day, for months and even years, gathering valuable data. With its lower orbit, the station offers the advantage that the ground receiver can be smaller, less costly, and not so complex. This experiment would open for consideration a spectrum band that is relatively untested for space applications. Sun's power will be relayed via millimeter waves at a frequency between 145 and 220 gigahertz. Currently used in medical imaging, millimeter waves are thought to be efficient energy carriers and suited for shorter transmission distances. Shorter distances could mean smaller, less expensive receiving stations and much lower launch costs. A single reflector satellite could be launched into a sun-synchronous orbit nearer to Earth with a heavy lift rocket, such as the Falcon Heavy. A longer-term goal of this experiment is to provide a path forward for future space solar power endeavors, including installation of a solar power grid in space. The sun-synchronous model is thought to be realistic, relatively immediate, and less expensive. This approach fits with the plans of Japan, India, and the United States to achieve space-based solar power by the end of this decade.
Experiments involving wireless transfer of electrical power have already been done successfully here on the ground. The International Space Station project will be the first long-term test delivering electrical power from space to Earth. The implications of this test for science and for society are enormous. If it can be demonstrated that the process for delivering greater concentrations of energy to designated locations on Earth, if that can be done economically in a way that is environmentally safe, it will mean that we can greatly reduce our dependence on the burning of fossil fuels. From space, we can provide to all nations on Earth a reliable source of clean and renewable electrical power for generations to come.